Hi guys, today I will be explaining you important topic which comes under the basic concept, and that is the compiler. The reason behind explaining you compiler in the very first session of this course is because guys, this compiler will be required in every program. So whenever you build or whenever you compile any program, then this compiler comes into account. So just to explain you how the coding works, it's not enough at all. You should be knowing guys what all processes are involved in executing your output, what all things are going in the background, what all things are required, how the process goes on in order to from stage to stage. So this is a very basic concept, and that is the reason I'm covering it under the basic concept guys. And also one thing, this topic is very important for interview perspective. The reason, because the interviewer will not only be interested of how you are coding, but will want to know whether your all basic concepts are clear, because it's very basic. It involves all the processes which is done, which is executed in order to execute your program, your C program. So that is the reason I'm covering this topic, because my course will contain coverage of all these basic concepts. I will explain you each and every concept so that your all the concepts will be cleared and you will be learning C from the scratch, and also you will love it if whenever you find the reason why this thing is working, you yourself will be very much interested in knowing what all the processes are going in the background, what all things, how it is done, and all the details about it. So guys, let's start. So the compiler. The compiler, it is a process to translate the high level language, that is the C language, into the assembly language. So guys, whenever you're writing the program in the C language, and when you compile or when you build your program, in that case, this compiler, it will translate your program which you have written in the C language into the assembly language. So guys, let us understand how the program using the compiler will be executed on the host machine, so that you will get a clear idea of what the compiler is, what it is doing exactly. So let's see the block diagram for the program execution. So this is the block diagram guys for program execution. So it contains preprocessor, compiler, assembler, linker, loader, memory. All these processes are involved. Whenever you are compiling your program, these stages are being involved in executing your program. So let's see one by one. So what is preprocessor? So guys, whenever you're writing a program in C language and when you compile, in that case, the preprocessor will take the input as a source code of your program, and it will check whether there are any preprocessor commands in it. If it finds any preprocessor commands, then it will work on it and it will create an expanded source code which it will pass it to the compiler. So guys, in my first session, I have explained you in detail what is preprocessor, because it's a very basic concept. That is the reason I have covered in my session. I have explained what all the details. So preprocessor supports 4 types of features. That is a preprocessor directive. So I have explained only one of them, preprocessor directive, that is file inclusion. The reason explaining only one of them out of 4 in the first session of this course is because guys, that one preprocessor directive, that is file inclusion, will be used everywhere in your program, and it's very basic, you should be knowing. So that when I'll cover next, I'll cover the chapters, like I'll cover the elements which is required to complete the C, and then data types, variables, all these topics, functions, pointers, which I'll cover. The various terminologies will be used. So guys, you should be aware of what all the things are required, what all things, these are the very basics. So you should be knowing from the scratch guys, and that is the reason I've covered this preprocessor in my first session on the basic concepts. So I'll cover in that manner all these concepts under the basic concepts, so that we won't be like, you all will be in the state that you all will be knowing each and everything from scratch. And you can refer that session of the preprocessor for reference. But to repeat again, what does the preprocessor do? It will take the input as the source code of your program. It will check whether any preprocessor commands. So preprocessor commands, I also explained the detail in the first session. Again, to repeat, preprocessor commands, like for example, if you are doing hash include some file name, that instruction is preprocessor command. So it will check whether this type of expression is commands are present. If it is present, then it will work on it and it will create an expanded source code which it will pass as an input to the compiler. So now comes the compiler into picture. So what the compiler will do? Compiler, it will take the input from the preprocessor, it will compile the program, that is, it will check whether your program is correct syntax wise. And if some error occurs, if some syntax error comes, then it will throw the compilation errors. So you need to resolve it. If there is no compilation error, if your program is well enough good syntax wise and many checks which compiler do, then the compiler will convert whatever input it gets from preprocessor, will convert into the assembly code which it will be passing to the assembler. So guys, in detail I explain you about the compiler after explaining this block diagram. This is the process which is involved when you are compiling your program. So you should know what all stages are involved, then we will focus on the compiler. So just understand, compiler will compile the program, will check whether your program is correct syntax wise. There are many checks which it does. I'll explain you what all checks it does, how it does after explaining this block diagram. So it passes the output as assembly code and that will be an input to the assembler. What assembler will do? Assembler will take the input as assembly code and it will convert into the object code or machine code that the machine understands. So guys, whatever output it gives to the input as a linker. So guys, what is linker? Now till compiler I explain. So let me give you an example. For example, for compiler I'm explaining. If you are writing any program which is calling a printf function, so compiler will check whether you are calling the printf function, it's okay, but whether you have included the header file. I have explained in the first session what is header file. It contains the prototype or declarations of the function, so it will check whether you have included the header file as you are calling printf. So yes, if you do hash include stdio.h, this is a header file wherein this printf is declared. If it checks yes, you have included, when and good, so it won't give any error. But who will check the definition? Where is the definition of printf? Who will check? So comes into account linker. Linker will check where is the definition of this function. So in this manner, so till assembler you are getting the machine code or object code, so that is not executable. So to make it executable, linker comes into account. Linker checks for the definition of the function. So when you get the declaration is checked by the compiler, all this, and linker will check the definition. So by this all things will be complete. You will get the declaration, definition, finally you can create an executable. So the linker, it will link the sections of your code of your program together in order to create an executable. So linker, it will link this object code or machine code with the library file. So library files has the definition of the functions. So for printf is defined or is implemented in the library file, that is stdlib file. So the linker for that case will search where this stdlib is present, where this library file is present, so that it can link the object code with that library files in order to produce an executable. So your it will produce an executable so that you can execute that program. After creating an executable, it will be passing to the loader. What the loader will do? Loader will load this executable into the memory in order to execute your program. So this is how the process works whenever you are compiling any program. So you can understand guys what all stages are involved in getting your output to be produced, like preprocessor, compiler, assembler, linker, loader, and then load into the memory. So all things are involved. So let us now see the details how the compiler works. So guys, this is a block diagram for how the compiler works. When I say that the compiler compiles a program and check the program whether it's correct syntax wise, and there are many checks, that means, what does it mean? This block diagram will clear all those concepts. So let's see one by one. Lexical analysis, syntax analysis, all these things are explained you guys. These are all these terms are all stages which are involved, which compiler passes. So why the compiler is doing all these stages in order to check whether your program is correct syntax wise, and there are many checks actually. So that if error occurs, it gives compiler error. So what is lexical analysis? Lexical analysis is where you are writing your program in C language. So that C language is having C instructions. You are using some keywords like if, else, for, whatever you are doing programming. If you are finding whether the number is prime or not, you are using if condition. So if whatever checks you do, you are using for loop, anything you use. So whatever C code you are doing, compiler will cut all this code into different tokens and it will categorize. For example, for keywords, it will categorize keywords. It will find all the keywords and it will categorize into the token name as alphabets. For void, return, it will take out all this part of your code and it will categorize into different token, that is punctuate. For keyword, like for not keyword, for if, for ID, for real, numbers, all these stuffs it will find in the code, search in the code, and it will categorize into type token. So it will, in this manner, it will take small pieces of your code, and that is also called as a sequence of the characters from your code, and it will categorize into different tokens. So what it will remove the comments. If you are mentioning any comments in your C program, guys, again to repeat, comments I've explained in detail in the first session, wherein I have covered 2 C programs so as to make you feel C. Again, to repeat, comments I will also cover under the basic concept. So don't worry, guys, I'll cover comments under the basic concepts, and it's a very important topic. Comments is just a documentary part of your program which will detail out what is the objective of your program. So I'll explain in more detail in my next session. Also, for reference, you can refer the earlier session also. Okay, guys. So in case of lexical analysis, what it will do, it will check, it will categorize, it will cut the pieces of your C program into different and categorize into the different tokens, and it will remove the comments as well as it will remove the spaces which are there in your C program. So thus this lexical analysis is done. So what is syntax analysis? Then in syntax analysis, it will check whether any grammatical mistakes is done. For example, if you have missed any semicolon, then it will give you a compile time error. So this is done by in syntax analysis. Then in semantic analysis, it will check if you're using any variable, whether you have declared that variable. So if you are doing assignment of one value to another value, whether these are done within the compatible data type. So all these checks the compiler will do. So you guys, you can understand that it does lexical analysis, divide your code into different tokens, categorize into tokens, removing the comments as well as space. In syntax, it will check whether you have done any grammatical mistakes. In semantic analysis, it will see if you are using any variable, whether you have declared it before using it, an assignment of the values you have done, whether it's between different compatible. So all these checks are done by the compiler. Then after that, it will create an intermediate code generation. So guys, this is very much important. The reason, because if this was not there, then you need to create a whole native compiler for dedicated machine specifications. So what does it do? So it will convert into intermediate code, because for different machines your compiler need to be modified. So that is the reason this compiler is involving all this process in this intermediate code generation. So you don't need to create a different native C compiler for different machine specification, and that is the reason it is creating this intermediate code generation. So it's very much required for the user to avoid burden to create a different whole native C compiler for different machine specifications. So guys, I hope you understood what is intermediate code generation. So just a second, guys. So after that, the stage which is involved is code optimization. So what is this code optimization? So it will remove unnecessary data which is present so as to speed the compiler process. So this is very much required for the optimization purpose, because it will speed in your compilation process. And then final, which is done, is the target code generation, which means it will create the output in assembly language. So guys, you understood, right, what all steps are involved, how the compiler checks, how the compile gets to know whether your code is without any compilation time error. That is, it will do this all these lexical analysis. Again, to repeat, it will divide your code into different and categorize into different tokens. Okay, and then syntax analysis, wherein it will check whether you are writing the instruction without any grammatical mistakes, whether you have missed semicolon, etc. Semantic analysis, wherein it will check whether if you are using any variable, whether you have declared it if you're assigning any value to another value, whether that assignment is between the different compatible data types, then intermediate code, which is very much required, as I said, this is required because if this would have not happened, then you need to create whole native compiler for different machine specifications. So this all is done by this compiler. It's very much required. Then code optimization to speed in your compiler process, target code, that is assembly language. So guys, today I'm done with this explaining of the compiler. In the next session, I will cover other basic concepts so that when we start our very first chapter explaining the C program, you will the terminologies which I'll be using, you will be having a clear idea, as I'm covering all those terminologies in this basic concepts. And guys, it is very much important because you should be clear all with these basic concepts, and it is very much important interview perspective. Interviewer will not only interested in how you are coding, interviewer will also be interested what all processes are involved, whether your basic concepts are clear or not. So we will have lots of fun, guys, in next session. Be ready. Thank you, guys. Thanks a lot.